Hello, in this video I'm going to give a short overview of Assignment 2. You can find the instructions and other materials for Assignment 2 under the Assignment 2 block on Moodle. Let's have a look at the instructions. So Assignment 2 is a room usage app. This is an app for a client, in this case Monash University, that is used for collecting information on rooms, and particularly about utilisation of space, lights, and heating and cooling. So the idea behind the app is that people can go around and go to different rooms, enter the building address, the room number, whether the lights are on, whether the heating and cooling is on, the number of seats that are in use, and the number of seats available in the room, and save this. And the app stores a set of these observations and can display various information on these observations. In fact, this is something that Monash actually do collect information on, so this is quite a realistic project. We give you a skeleton for the app, so for example you don't need to create this HTML form. We provide that to you. You can style it and display it in your own way if you wish, or you can just use our template. What you're doing is writing all of the logic behind the app, in this case the information that reads the form, constructs class instances, saves these to local storage, and then loads those and displays them for other pages of the app, and we'll step through that functionality now. So as I said, the skeleton we give you, which we'll take a look at in a minute, has 4 HTML pages. It has 4 corresponding JavaScript files, one for each of these 4 pages. It also has a style file, and then it has 2 additional JavaScript files. One is a shared JavaScript file, which you can fill in, which is intended as code that is used by all of the 4 pages. And finally, a 6th JavaScript file called utility.js, and that's one where we provide you some useful code, and that's one you can't modify. So let's have a look at the required functionality for the app. So first off, we need to implement a room usage class, and a room usage class is a class that holds all of this information collected by the form here. We can see a list of these attributes: room number, address, lights on, heating, cooling on, seats used, seats total, time checked, and various information on their data types and other restrictions. Other restrictions are there because you need to do some checking and validation of the information entered into the form. So we also have a class called room usage list, which is a class that holds a number of room usage observations. So this is sort of a container class that also includes some useful methods. Feature 3 describes this page that we're looking at over on the right here, the new room observation page, and what this needs to do is obviously have the form with this information, have buttons that you can clear, and the user can enter, type in a building address, type in a room number, and we'll see this work in just a moment. Also, as part of this is a location tracking feature. So we get you to use geolocation, that is the GPS on the device, to identify your location, and use a process called reverse geocoding, where this GPS location is passed to a web service, and what we get back is a building address. Not always perfect, but reasonable, saves you entering it. So in this case, 17 Rainforest Walk. I'm going to enter a room number, maybe 123. Say the lights are on, the heating and cooling is off. There's 15 seats in use out of 22 available seats. When we finish here, we can click save. We get a little message that the observation was saved, and we can check that because the next feature of the app is the requirement for you to be able to store this information. So make sure that the observations are persisted, so if we load a different page of the app, that information should still be around. So again, this mirrors very closely our activities that we did in the Week 7 prac and also the Week 7 workshop. So you need to be able to load the room usage data from local storage, which means creating an instance of the room usage class and initializing it from the simple object version, and then doing the same for each of the observations. Again, there's a little bit more information here to describe to you how you can do that for the date class, for example, which is another thing that's not shown on the form, but is the time that the observation was taken. So feature 7 describes the observations page of the app. Let's have a quick look at what that looks like. Basically, it's just a list of all of the observations. Now you might notice here there's 239 observations. Obviously, it's not realistic that you're going to wander around as you're debugging and collect a lot of these observations. So we provide for you a JSON file in the same format that you should be saving your information to in local storage. So you can, once you've created your classes and the code to save to and load from local storage, you should be able to use the web inspector in Chrome and paste that JSON in there and then load from it and have the full set of observations that we've generated here. So I can quickly show you what that what that JSON looks like. So here's the JSON. At the top you have a JSON version of the room usage list class, which just has a room list attribute, which is an array, and each of the elements in the array is one of our room usage classes, just turned into JSON, and you can see it has all of the attributes that were listed in that table that we saw. And for the date, if you call to JSON on a date, this is what you get, a string representation of that date. Okay, so back to the observations list. In addition to just showing the observations, and again we provide you some sample HTML for doing this, and you can populate it in the same way that you do for the airports example in week 9 prac class, or if you want to display it differently, you can, as long as you show the same information. There are a couple more features to this page. One for deleting observations, so that is each element here has a delete button, and if you click on it, it should delete that entry from local storage and reload the page. And obviously when it deletes it and then reloads it, it's not going to be there anymore, so it won't display it again. And we give you some hint on the easiest way to do this by creating some HTML which includes the index of the observation within their room usage list array. We also get you to implement some search functionality. So we've written the search bar using MDL up here, and this is just a text field that displays when I click on it, and I could type something like New Horizons. We don't have any of those. Let's say research. There we go. And we see just the entries where this search term matches our building address. So obviously this builds on some of the work we've done using text fields in the past, and we give you some hint that you can use a property called onInput and set a callback function, and this will be called every time the user types a character within the text field. The next thing we get you to do is write a method of the room usage list class, which takes the big long list of observations. In this case, I think there were 239 of them, and it buckets those observations into different individual buckets based on some criteria that you give it through a function you pass. This method is called aggregate by. You pass it a function that takes as input a room usage class, and it returns to you a string, and depending on what that string is that it returns, it uses that for the buckets that it put things into. So as an example, for example, if you passed a function that returned a room string for a given room usage instance, then the observations would be split into separate lists, one for each different room. As another example, if you wanted to aggregate by time and you had this list of room usage observations, we've just colored them differently based on the hour. So this one's purple because it's 8 a.m. This one's also purple because it's 8 a.m. as is this one. This one's 10 a.m. we've colored it yellow. This one's 5 p.m. we've colored it green. This one's 9 a.m. And what this method should do is go through each of the observations, and as it encounters one, if the bucket returned for it, which in this case would be the hour, just 8, if the bucket doesn't exist, it creates the bucket. If the bucket already exists, it adds that observation into the list contained in that bucket. So after this process, we go through all the observations, and at the end we have a number of buckets based on the different values that the function we gave to aggregate by returns. So there's a bit more detail describing this in the instructions. You can look through it. If you have any questions, you can ask us about it. This is probably the most technical, complex part of the assignment. But this bucketing process is used for the next two features, and in fact the final two features of the assignment. So one of these is the occupancy page, and the occupancy page does the bucketing shown in this diagram. It splits all of the observations by hour, and then it's concerned only with the hours for the working day, as in 8 a.m. to 5 p.m. or 6 p.m. I think the instructions might say. And what it does then is it displays the top 5 or up to top 5 entries in each of these buckets. And it does that based on the thing with the worst occupancy. So what it's showing here for 8 a.m. are the observations that have the lowest occupancy, as in this case, no seats in use. And again, we talk about how to do this with that aggregate by method that we've written. We also talk about how to order the observations using array.sort, which is a pretty simple process. And then finally, the last page of the app is the building stats page. And this one instead buckets them into different buildings. So we have 15 Research Way, 22 College Walk, 18 Alliance Lane, and you can see the number of observations tallied up here. So for 15 Research Way there were 2, for 18 Alliance Lane there were 4. And what it does for these 2 observations here and 4 observations here is it computes some averages for them. So the average number of seats in use across all those observations, the average usage of lights, and the average number where heating and cooling were on. And then finally there's this last entry called wasted observations, or wasteful observations I should say. Wasteful observations are those where the resources are on, that is lights or heating and cooling, but there's no one in the room. So it's obviously unnecessary if there's no one in the room, hence wastefulness. So the final thing we have is that we want you to visually highlight the buildings with wasteful observations. And if we scroll down, we should see one. Yeah, okay, so here's one that has wasteful observations, and you can see this has just been colored in red, or kind of looks pink here. So that's the code. That's worth 12% of your unit mark together. There's also some technical documentation that's required. A basic project management plan that has the kind of things that we talked about in our workshop when we were discussing the project management plan. We also get you to describe a brief overview of the design of the app and do a class diagram that details the 2 classes that are used in the app. In addition, we get you to create a short user guide, but this is actually a very short task, so it only needs to be a page or 2, that just details the different screens of the app and the features that are there, as well as any known bugs or limitations. The assignment also includes a presentation component. I should say the technical documentation here is together worth 6% of your mark, and then there's a presentation which is worth a further 6. So all up, this assignment together with the presentation is worth 24% of your unit mark. As before, with the first assignment, it's moderated by CATME, and it's also moderated by your use of the different tools that we use for communication, which are detailed down here, which is your use of Git for obviously working on the code. We expect you to make commits to Git and see the progress of the code development there. That you use Asana for tracking tasks as you work on the assignment, and use Google Drive for the preparation of the 2 documents. Okay, one final thing I'll do is I'll just show you the skeleton code for the app. So this is the HTML for the observation page. These are the form elements you see listed here, and we can see various elements have IDs that can be used to refer to them. The buttons are down here, and just standard button elements. You can add handlers to these in the same way that we did in various workshop examples. For the second page, observations, we provide you some example cells that display here. One that's a kind of message cell if you just wanted to show a quick message to the user, and another couple that show actual observations, at least in our sample style. These are shown in observations.html. You can find the overall page HTML, and then a section here that details example observation cards. So here's one observation, and then that same observation is just repeated underneath, and the code for that top cell is shown here. The third page of the app is occupancy. Again, it pretty much does the same thing. We've got a bit of HTML showing samples for 2 times, in this case for example both 8 AM, and you can find them listed down here and commented. So there's the first one, and if you wanted to find the part of it that refers just to 24 Innovation Walk, that's just this bit here, which is a building entry, and then there's another building entry underneath. So obviously when you generate the HTML for these pages, you're going to need to use the same sort of technique we've been using in many workshop examples with inner HTML and modifying the content that's shown within this content element. The final page of the app, building stats, is much the same. There's a building stats.html file, and that one shows again some sample HTML that you can make use of. Alright, thanks for watching. Please let us know if you have any questions about the assignment.